Okay, solving first order DE using Laplace transform. Okay, so say for example we have a DE consisting say dy over dt. Okay, so if we are to get the Laplace transform of first derivative of y with respect to t, that will be equal to the general formula of the Laplace transform, wherein the integral of e times negative st times dy over dt times dt, okay, from the limits 0 to infinity. Now, using integration by parts, Laplace transform of dy over dt will be equal to y times e raised to negative st from 0 to the infinity plus s times 0 to integral of e times negative raised to negative st times y dt from the limits 0 to infinity. So this is using integration by parts, which we will not specifically go over. So we will just proceed. As t approaches infinity, the term y times e raised to negative st approaches the value 0. Therefore, Laplace transform of dy over dt will be equal to s times transform of y as a function of t minus the value of y when t is equal to 0. So this is our general equation for Laplace of first derivative. Okay, so let's have an example. Then we will use this general formula in getting the Laplace transform of dy over dt. So for example, let us solve the dy over dt equals e times raised to t, and y when t equals 0 is equal to 2 using the Laplace method. So we will take Laplace transform of both sides. So the Laplace transform of dy over dt is equal to the Laplace transform of e raised to t. Okay, now using this formula in getting the Laplace transform of dy over dt, so we have s times the Laplace transform of the function of y as a function of t, okay, minus the value of y when t is equal to 0 equals, we already know the Laplace transform of e raised to t, that is 1 over s minus a, which is equal to 1. Okay, now for we will be leaving this term in one side of the equation, so we'll have Laplace transform of y as a function of t is equal to 1 over s minus 1. We'll have plus y as when t is equal to 0, and then we'll transfer s here, so it will become 1 over s times s minus 1, and then y when t equals 0 over s. Okay, so we know that y is equal to 2 when t is equal to 0. So therefore, we will get the inverse, so that we'll have y as a function of t at one side of the equation, and that will now be equal to the inverse of 1 over s times s minus 1 plus 2 over s. Okay. Now, in getting the Laplace, the inverse Laplace, for this term, let's try to use partial fraction to separate the factors in the denominator. So we'll have a over s plus b over s minus 1. Okay, so multiplying everything by this denominator, we'll have 1 equals a times s minus 1 plus b times s. So we'll have as minus a plus b times s. So for terms with s first degree, we'll have 0 equals a plus b, and for the constants, we'll have 1 equals negative a. So therefore, from here, we have a equals negative 1. And if a is negative 1, b therefore is equal to 1. So therefore, the value 1 over s times s minus 1 is equal to negative 1 over s plus 1 over s minus 1. So substituting here, we now have function y as a function of t is equal to inverse of negative 1 over s plus 1 over s minus 1 plus 2 over s. Or distributing, we now have inverse of negative inverse of 1 over s plus inverse of 1 over s minus 1 plus 2 times inverse of 1 over s. Okay, so y as a function of t therefore is equal to, okay, we'll have negative times inverse of 1 over s, that is negative 1, plus inverse of this 1 over s minus 1, that will be plus e raised to t. Then we have this one, inverse, 2 times inverse of 1 over s. So we have plus 2. Okay? Or we have y as a function of t is equal to e raised to t plus 1. So this is now the particular solution of the dy over dt equals e raised to